Hello everyone. So this is part 2 of scientific notation video, and that will be on the back page of your notes. So I want you to write down complete the statement with greater, less or equal sign. So what we have given with those examples, we will have two numbers on the left and right, and after we simplify from scientific notation to a standard form, we will be able to tell which number is smaller and which one is larger. Alright, so now we have 6.9 times 10 to the third on the left and 6.9 times 10 to the fourth on the right. Well, in the previous video I showed you how to convert the numbers from scientific to standard form. So let's go ahead and do that. We'll do a little bit more practice with this, and at the same time we'll be able to compare numbers. So if I have 6.9 times 10 to the third power, it shows as positive power means we need to move the decimal point to the right 3 times. So my new number will be 6, and if you move 1, 2, 3, it means we gotta fill out 2 zeros. So it will be 6900 here. Then this one is 6.9 times 10 to the fourth, so we have to move the decimal point 4 times to the right. 1, 2, 3, 4, which means we're going to have 3 zeros here. So 6, 9 with 3 zeros. Now, down here we have 6,900. Right here we have 69,000. Which one is the largest number? Well, of course, 69,000 is the largest number, so this is how we're going to place the inequality symbol. And we will say on the left side is less than the right side. Now, take a look at the second example. This one, it says 10 to the 18 and 10 to the 10. Well, those are big numbers, and we will have to move the decimal point 18 times. It looks like we don't have much room. So what I want you to do is I want you to compare the numbers. This one is 4.3 and this one is 4.3. They're exactly the same. So the only thing you have to decide now, which one, left or right side, has more zeros. And if this says 18 and this says 10, which side will have more zeros? Well, definitely the left side will have more zeros, which makes left side greater than the right side. So the inequality symbol in this case will go in this position. Okay, so now next example we have given is when we have 3.8 times 10 to the negative 4 and 3.8 times 10 to the negative 10. Now imagine if you have a negative 4 here, you have to move the decimal point to the left 4 times. Okay, 1, 2, 3, 4. And you're going to fill out 3 zeros. This one, it shows you that there's to the negative 10 power, so again we need to move the decimal point all the way to the left, but this time we're going to move it 10 times. So if this is 0.0038 and this one is a really long number that goes all the way to here because we have to fill out so many zeros, which one of those two will be larger? And which one smaller? The one that has less amount of zeros or the one that has greater amount of zeros? Well, this one has a lot of zeros, which means this number on the left is greater than the number on the right. And if you want to, you can actually fill out those, and the answer here will be 0.5678938. So look at this. This is what this number is equal to. You can even use it in your calculator and type 3.8 times 10 to the negative 10 power, and you're going to see that this number will pop up. Same thing over here. And when we compare those two numbers, which one is larger? Well, definitely this one is larger than that. Okay, in the next example, there is something a little bit interesting. We have 7.8 times 10 to the negative 8 here, and on the right side is 0.78 times 10 to the negative 7. So look at those two numbers are different. We can't compare the exponents like we did it up here for those examples, because those two are different. So let's go ahead and rewrite those in standard form first. So decimal point here we have 8 jumps to the left because it's negative, so we're going to make this number smaller. 1, 2, 3, 4, 5, 6, 7, 8. and fill out with 7 zeros. So we have 7 zeros, 7, 8. Let's rewrite the problem. 0.1234567 This is what this scientific notation is equal to as a standard form. Now this one, we have 7 jumps to the left. So will be 1, 2, 3, 4, 5, 6, 7 jumps. And we have 1, 2, 3, 4, 5, 6 zeros to fill out. And let's go ahead and copy this. 0 point, and we have 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros, 7, 8. Alright, well, let's take a look how many zeros we have here and compare the numbers. So there are 2, 4, 6, 7, 2, 4, 6, 7. Okay, well, both of those have an equal amount of zeros and 7, 8, which mean left side is equal to the right side in this example. So in this problem, we have two numbers equal to each other. And the last example, very similar to what we just did, we have negative fifth to the negative 4. So let's go ahead and just practice with another example like this. We have 5 jumps here to the left to make it smaller because again of the negative exponent. So I'm going to count 1, 2, 3, 4, 5 jumps, and I'm going to fill out those with zeros. So my new number is 0.1, 2, 3, 4 zeros, 4, 6, 3. And this one, here is the decimal point, and we are doing negative 4 jumps to the left. 1, 2, 3, 4. Fill out those zeros, and I'm going to put 0.1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, 4, 6, 3. Compare both numbers again. We have 2 4 zeros here, 2 4 zeros here, same number. So again, we have equal sign between left side is equal to the right side. And that's all. That is how we compare numbers in scientific notation. Thank you again for watching the second part of scientific notation video. Hope it makes sense. Otherwise, we will definitely do more examples together, and we'll discuss questions if you have some. Have a great day, everybody.